All right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still going over our understanding VITS module. In case you forgot what VITS stands for, it was the Visual Transformers, VITS. So let's have a look at what we went over today. Now, we didn't write down any code today. We didn't get to the coding aspect of the module. Like I said, we just started the module, so we're still just taking notes. So let's pick up with some light reading. So yesterday we left off with the to understand how and why the attention and also the transformers are used in natural language processing, we'll take the following example, which is that of translation, which we are used to doing with the Google Translate. For this example, we will be translating the text from English to French. So this is our English sentence here we're going to be translating, and we're going to translate it into French. And as you can see, this is the French translation. Initially, the kinds of deep learning techniques which were used in solving these kinds of problems that is taking us from one language to another were the recurrent neural networks, or the RNNs. The way the RNN works is quite simple. We'll start by putting the text in a text box. Let's take a look at the example sentences again. So you can see here we have our example sentences, and we have these little boxes above them here. Notice that we added some extra blocks to our example sentences. These blocks are recurrent neural network blocks. RNNs were one of the first learning-based models used in natural language processing tasks, like the case with this translation. Let me fix this really quickly. 1 second. All right, we do that. The way this works is we have our initial text, or we have our source, that's the English text. Then we have the target, which we get to generate, or which we want to generate, which would be the French. So this is our source, and this is our target. We want to go from English to French. So initially we have the input and output, which we are going to train on, and later on we pass in some random input. We expect to get a reasonable output. So this is our reasonable, or this is our random input, and this is the reasonable output we want to generate. Input and output. Let's move down a little bit more. 1 second. The way that our input is structured is that each word is called a token. For example, we have 5 tokens in our input sentence. Each token gets converted into a vector and then gets passed to the RNN block. We can carry out some simple computations like multiplication and addition, and that information will be passed from one block to another, hence the term recurrent neural network. Now that's why I left it, because I wanted to focus a little bit on the RNNs. I know we've gone over this topic before, but it's always good to always double back and make sure we have a grasp for what we're learning, so we know exactly what we're talking about. So these are our RNN blocks here. This is our source. So what they're saying is these tokens get converted into vectors, which get passed into this RNN block, and all of this information gets passed along into the next RNN block here, which already has its own vector information from this token here, and all these together get passed on to the next one, and so on and so forth. Hence the name recurrent neural network. So basically, that's what we did today. We just brushed up on some more notes and things that we need to get a handle on before we move forward writing code for this particular module. But as we move forward, I will keep you posted every step of the way as usual. For now, it's the Python Papi. You guys stay Gucci.